Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we will be discussing sample question paper for CBSE class 12th physics term 2 exam. So here in the term 2 exam, remember your time will be 2 hours and your maximum mark will be 35 marks. Okay. So here 3 sections will be there, section A, section B, section C, and already about questions, number of questions, how much mark is coming from each sections. So already we have discussed in the previous video. Okay. So the description is given in the description box. Please check for the section wise marks and also chapter wise analysis for term 2. Now in this video we will be discussing section A part, solution, how to write solution for the term 2 physics paper. Okay. Now let's come to the topic. Now here in the question number 1 in section A, okay, already I explained in section A it will be 2 mark each. So each question will be how much? 2 marks. Each question will be 2 marks and you have to solve only 3 questions in this section. Number 1 it is telling, in a pure semiconductor crystal of silicon, if antimony is added, antimony is a pentavalent impurity basically, if impurity is added, then what type of extrinsic semiconductor is obtained? Draw the energy band diagram of this extrinsic semiconductor so formed. So here 2 part of this question is there. So in the first part what they are asking? So they are asking, you are having a pure silicon or basically intrinsic semiconductor. In this semiconductor you are adding antimony. Okay, so it is a pentavalent impurity. Pentavalent impurity. If you are adding, then what is forming? This is what is forming, that is one asking question. And another question, you draw the energy level diagram. So 2 part is there, 2 part will give answer. Now first let me give the idea here. If a pure silicon, antimony or pentavalent is added, then definitely what type of semiconductor will form? Now N type semiconductor will form. Okay, so this is your basically extrinsic semiconductor, it is your intrinsic semiconductor. Remember, in intrinsic means pure form semiconductor, if a pentavalent impurity is added, then N type extrinsic semiconductor is formed. If a trivalent impurity is added in place of arsenic, if I am telling a trivalent impurity like indium or gallium, then it will be P type semiconductor or P type extrinsic semiconductor. Okay. And remember, antimony and phosphorus, this both are pentavalent. When it is added, it is like pure form will become impure form. So this is the idea basically. And energy level diagram means what? Now you have to do some valency band energy and conduction band energy, then after you have to show that one. So this is what the 2 party here you have to do. So first part you have to write something up to this one, how it is formed, what type of semiconductor is formed, and the second thing what is that? Now drawing. Okay. Now let's write the solution here. So here if a solution I want for that question number 1, what I can write? Now I will give I part. So first I want to inform that here if antimony is added to a pure silicon, then N type extrinsic semiconductor is formed. Extrinsic semiconductor is formed. Semiconductor is formed. Okay, formed because antimony is pentavalent. Antimony is pentavalent. Okay, so when pentavalent is added in a pure silicon, then after it will extrinsic, N type extrinsic will form. Okay, and here you can little highlight this word. So N type extrinsic semiconductor will form. So first part is over. So one more question you are getting here from that question number 1. Now second thing is basically you have to do energy level diagram. So write here what is energy level diagram. Energy level diagram of N type extrinsic semiconductor, N type extrinsic semiconductor. So, energy level you try to write. So, how it will be energy level diagram? Now, first you take here one band of energy. So, this band of energy is called valence band of energy, and this is your conduction band of energy. And here you can have different energy level. So, here it will be different energy level will be there. So, here another energy level, here another energy level, here another energy level, here another energy level. This also similar way, here energy level, here energy level, here energy level, here also energy level. So, whenever there are many energy level, there is a range of energy levels that forms basically energy band. So, this is the valency band, this is the conduction band. And remember, the lower the bottommost energy level is called basically conduction energy level, and in the valency band energy, valency band, the topmost energy level is called basically valency band energy level. So, write it is EC, it is EB, and here you can write this is your conduction band, this is your valency band. Okay. Now, when N type like antimony is added to a pure form of silicon, then what happens? Now, antimony gives one electron to the crystal, then there are number of electron in the that crystal, it will increase. So, number of electrons basically increase as compared to holes. After donating, that antimony will become positively charged, like one energy level they will form, that is called basically what? Donor energy level, that is called donor energy level. So, you can give here another thing, that is donor energy level, donor energy level. Okay. So, remember antimony is donating one electron, after donating electron it is becoming what? Positively charged, and here it is increasing the electron concentration. So, here this you can give also ED, that is your donor energy level, and here to here, so one donor energy level is there. This energy is nothing but how much you can write? 0.01 electron volt, 0.01 electron volt. Okay. So, this is the energy level diagram, and here you can give some like electrons, here some holes, electron in the valency band, here also you can keep some electron holes, this type of things you can keep it here. Okay. So, this is the idea, and this energy level you can give, this difference is basically Eg. So, this is the energy level diagram for N type extrinsic semiconductor. You will have valency band, conduction band, and here EC, the bottommost conduction band energy level is EC, and topmost valence band energy level is EV, or like valence energy level, and in between one donor energy level will come, which is near to conduction band, just below the conduction band, and here this Eg is nothing but electron energy gap. Okay. So, you can write also this Eg is nothing but how much? Okay, electron energy in energy level, conduction energy level minus valence energy level, that is your energy gap. So, this much idea you must do for your energy level of diagram of N type extrinsic semiconductor. Okay. So, here definitely you will get 1 mark, and here 1 mark. So, total 2 mark you will be getting here. Understanding clearly? So, this is the idea how to write. Okay, simple thing, do not extend more language and all, particularly write what is needed. So, here this thing is needed, N type extrinsic semiconductor is forming or not forming, that is needed. So, note it down and do the diagram properly, mention everything here. CB means your conduction band energy, CB means conduction band, and VB means valence band, VB means valence band. Okay. Now, we will go to the next question, we will try to see what they asked and how to give answer for that. Okay. Now, question number 2 you see. Now, question number 2 telling consider two different hydrogen atoms. The electron in each hydrogen atom is in excited state. Now, asking is it possible for electrons to have different energies, but same orbital angular momentum according to Bohr's model? Justify your answer. And also one given or another question also given. Now, you see here what they gave in question number 2, they have given this is your internal choice. It is your internal choice question. So, here what they asked here, now either you do this or you do this. Okay, already in the last video I have described, there will be internal choice in the question. So, in the section A there will be one internal choice, and okay, either in question number 1, 2 or 3. So, here in 2 it is given what? Now, here either this you do or this you do. So, you have option here. Okay. So, you do not do half this question, not like that. Either do fully this or you do fully this. Okay. First let me complete this question, then after I will come to this question also. Okay. So, this is from basically what? Atomic physics. Okay. And last question. So, the last question was basically what? This is from the semiconductor electronics chapter, and this one is second question here asking what? From the atomic physics, and this one is your nothing but it is your dual nature, that photoelectric effect expressions, from there it is asking. Okay. Now, see here. Okay, now understand how to solve this question. Here, this is from what? Now, 2 hydrogen atoms are there. Electrons in atoms, in each atoms is an excited state. Now, is it possible to have electrons different energies but same orbital angular momentum according to Bosch model? Actually, it is not possible. Okay, and justify your answer. So, first this answer, this statement up to this statement, it is basically answer is no, not possible, first point. Second point what? Now, you have to justify your answer, why it is not happening. So, the two things you have to remember here. First is basically what? Now, you have to consider your energy is quantized, that means energy in nth orbit is basically what? Minus 13.6 electron volt by n square. When you study atomic physics, that time you will understand. For hydrogen atom, energy in nth orbit, okay, if electron in nth orbit for hydrogen atom, energy is basically minus 13.6 by n square electron volt. And similarly, angular momentum in nth orbit is how much? That is m v n r n equal to nh by 2 pi. Okay. So, here n is basically some 1, 2, 3 like that, it is called basically number of cells or number of orbits. So, here if you will take n value 1, 2, 3 like that, you will consider, then what will happen? Different value of E will come also, different value of L also will come. So, that is why energy of electron of different energy cannot have same angular momentum. So, these two lines should be there. Okay. So, how to write answer? Now, come to the solution here. Now, solution you write like this. First thing write, no, it is not possible for electrons to have different energies but the same angular momentum, because according to Bosch model we have En equal to minus 13.6 electron volt by n square for hydrogen atom. Okay. And electrons in a different energy level having different energies because of this value of n, different n values. So, that is why it cannot have same orbital angular momentum, because Ln basically nh by 2 pi. Okay. So, these 2 point is there, means definitely, and you are telling answer also no. So, definitely 2 mark you will get from here, okay, no doubt. Okay. So, first understand question properly, then after try to approach the questions. Okay. So, this is a little language based question, there are not that much things you have to explain, just explain what electron energy is quantized and angular momentum also quantized, different energy in a different energy levels, okay, different angular momentum in a different orbits. So, this is the answer you have to write here. Now, come to the next question. This previous question come here. So, here they are telling explain how does, okay, how does photoelectric current, okay, it is photoelectric effect question actually, and kinetic energy of photoelectrons emitted in a photo cell vary if the frequency of radiation is doubled, but keeping the intensity same. So, graphical variation in the above two cases. So, here case I, case 2I, definitely you have to write case I, case 2I. You have to explain how photoelectric current is varying with respect to the frequency change in frequency, and also how graph is coming for photoelectric current versus frequency. Okay. So, these two things you need to explain. So, first general idea keep in this thing. What is this? Now, photoelectric current increase or decrease basically depends on the how many number of electrons are coming out of the metal surface. Okay. So, this photoelectric effect basically what you know, metal surface is there, light is coming incidentting on metal surface, then here some photoelectrons are going out. So, this is the thing happening. Now, if you more number of photoelectrons, then more electric current. But remember, once from the metal surface, if it is achieving some threshold frequency, then what will happen? Now, electron already emitted, then after if you increase the frequency, then again extra electron will not emit. If extra electron is not emitting, then what will happen here? This photoelectric current will not change if your frequency is increasing, because here they are telling frequency is increasing. Okay, frequency becomes f becomes a 2f. This is the frequency of incident radiation. Okay, this is the metal surface, this is the incident radiation coming. Okay. Now, here this is the idea you have to write, and you have to do a graph also for that. So, that means photoelectric current does not change with frequency, means that there should be some constant graph will come. Okay, if photo current and frequency will do, there should be some constant graph. So, I point you have to write it does not change, and here if a photo current and frequency I will take, definitely I will get a graph like this. Second thing, understand kinetic energy, how kinetic energy of photoelectron emitted changes. Now, listen here, you know kinetic energy of photoelectron is nothing but how much? H nu minus phi. So, this is the Einstein's photoelectric equation. So, here what we write basically, now this is incident photon energy, and now listen, this phi is called basically work function of the metal. So, this is a fixed actually, suppose it is copper metal, so copper metal work function is fixed. Okay, suppose copper metal, it is some value, energy value needed to emit one electron. So, with that much energy you are giving one electron, it will emit. So, this will be fixed for metal surface. If you change the metal, then it will change. But here H nu is what? H nu basically you can understand like a directly proportional to kinetic energy. If a frequency, that H nu means nu is frequency, H is a Planck's constant. So, it is energy of the incident photon. If a frequency is increasing, then kinetic energy also will increase. That means there is some effect on kinetic energy of photoelectrons. Okay. So, that is why here what will happen in the graph, if we will draw. So, graph will be from this equation definitely a straight line equation, and here if I will take kinetic energy, and here I will take frequency, okay, then I will get a graph like this, some straight line graph will come. Okay. So, frequency you can write f or you can write nu, okay, whatever you can write f or nu, some constant graph will come in this case. Okay. So, these 2 points you need to write. Okay. Now, you go for this answer, how to write this answer. Now, here I point, right, give I point answer of this question, but remember in your exam you have to do only one question, either up or down. Okay. You do not have to do both. Here I am explaining, that is why I am doing everything. Now, first thing is what? Now, first thing is, okay, photoelectric current. Photoelectric current does not change with increase in frequency. Increase in frequency. So, this word you must remember and write. Increase in frequency, photoelectric current does not change. Okay. Because why? I can write because no extra electrons emitted if frequency is double. If frequency is doubled, no extra electron will emit. Now, if a variation you want to write, so graph actually you want to show. So, here photoelectric current, or you can write basically photoelectric current versus frequency graph we will do. Then how the graph will be? Graph will be like this way. So, here it will be photoelectric current. Okay. So, I am writing PEC, photoelectric current, and this is the frequency f. Now, here this photoelectric current does not depend on frequency after a threshold frequency. So, once threshold frequency is achieved, that means this is the frequency when photoelectric current happens. Okay, electrons emitted, that is the basically this one. After this, what is happening? How much increased frequency? There is no effect in the photoelectric current. Okay. So, photoelectric current I am writing PEC, you take in, it is in y axis, it is in x axis. So, your graph will be like this one. So, this is the first point, it is over. 1 mark question is over. Next point you have to write about the kinetic energy. Now, understand what about kinetic energy. So, here if I will go for kinetic energy writing, so number 2 I point I will write, okay, kinetic energy of photoelectrons, kinetic energy of photoelectrons, kinetic energy of photoelectrons increases. Okay, what happens? Increases as frequency increases. Frequency increases. Okay. So, how you are getting? So, here write some explanation for that also. So, you can take the help of Einstein's photoelectric equation. Okay, according to Einstein's photoelectric equation, kinetic energy of electron, or I can tell maximum kinetic energy of electron is basically h nu minus phi, where phi is work function of metal and h nu basically energy, or nu is basically frequency. So, whenever frequency is increasing, energy of the incident photon is increasing, h nu term is increasing as nu is increasing. Then if this will increase, this is fixed already. So, this kinetic energy will become more. So, here kinetic energy increases. Okay. So, here, but that means, or you can write here, if energy is increasing, then incident photon is giving more energy to the photoelectrons. Okay. You can write here. Okay. So, you can write, okay, increase in incident frequency increases energy of the incident photon, increases energy of incident photons, and incident photons impart more energy on photoelectrons, more energy on photoelectrons. Okay. So, this is the idea you can remember. So, if it will impart more energy on the photoelectrons, then what will happen? The kinetic energy will increase. So, kinetic energy of photoelectron increases as frequency increases according to Einstein's photoelectric equation, and increase in incident frequency increases energy of incident photon, and incident photon imparts more energy on photoelectrons, so that kinetic energy will increase. If a graph will do, so graph will definitely come straight line graph. Now, take kinetic energy here, take here, or I can write nu you can write, or f you can write, no issues. Now, here remember, so this is a straight line equation coming. So, in straight line equation, this is a y intercept. In y axis you have taken kinetic energy, it is a negative y intercept. So, work function will be here, phi will be here, and here it is a positive slope, slope is basically h coming. So, it will be positive slope graph, so it will be like this one, and here it will be nu naught, which is called threshold frequency. So, this is what? Now, this is your nothing but you can tell, okay, kinetic energy versus, okay, frequency graph, kinetic energy versus frequency graph. Okay. So, this much point you write. So, one is I point, one is 2I point. So, your question is over. Okay. So, you must understand what you need to write. First, you little think 1 minute what you need to write, then after go for writing and draw the picture also. Okay. So, successfully completed question number 2. Now, next move to the question number 3. So, what it is telling here? Name the device which converts the change in intensity of illumination. That means it tells something about light, something about photon. Illumination means like light, photon, to change in electric current flowing through it. So, that means there is a relation that telling something happening. What? Like a photon and electric current. This type of thing is happening there. And here actually remember, this is coming from the semiconductor physics, that semiconductor and electronics. So, plot IV characteristics of this device for different intensities, state any two application of this device. So, definitely it will be like a diode type, and this type of diode is using photons. So, that is what you can tell basically photodiode. So, what happens here? Photon get absorbed and it will basically give some electric current inside your device. Okay. Okay, so this device basically converting light to electric current. So, this type of thing is happening, and this device is nothing but as photon one is used, definitely this device will be how much? What it will be? Now, it will be, the device will be photodiode. Okay. So, it is using light, that is why basically photon thing is coming, and a diode basically it is a PN junction diode. Okay. So, it is basically it is a similar regular semiconductor PN junction diode, but thing is what basically, now here PN junction diode we are just normally using in the circuit board and all, but here it is using the photons. So, photons get absorbed and converts to electrical current. So, this type of things happens. Okay. So, this type of thing you have to answer, you have to write basically name the device, that means photodiode, answer is over. Plot IV characteristics means you have to plot current and voltage graph. Okay, you have to take y axis current, x axis voltage, you have to plot some graph that is called IV characteristics for that diode, and again you have to understand one application. So, that means you can application you have to write, two application you have to write here. So, here these 3 points you need to write for this question. Now, come to answer here. So, first thing I will write here, answer will be how much? Now, here if I write answer for this question, so number I, so answer will be first what? Photodiode. Answer will be photodiode is the device which, okay, see the question and write from there. So, device which converts the change in intensity of illumination, which converts change of intensity of illumination to the change in electrical current, change in electrical current. Okay. Flowing through it, electrical current flowing through it. Okay. So, this is the first point you are over. Second point is what? Second point is IV characteristics. So, write directly IV characteristics of photodiode. Okay. So, there are different types of diode we will study in semiconductor and electronics. So, here they asked about the photodiode. So, IV characteristics I will write like this one. So, here I have to take current I, here I have to take voltage V, this I have to take in volts, and here this I have to take in milliampere, this is the forward current, and this one I will take in microampere, it is your reverse current, and this is your basically reverse voltage, you can write it is basically reverse bias. Okay. So, basically in PN diode when you study that time forward bias, reverse bias, this type of things comes, and IV characteristics also comes. And here if a graph I will draw, so graphs will be like this type of graphs I will get. So, let me write here. So, this type of graphs will get, and here I can write intensity I1, this intensity I2, this intensity I3, this intensity I4, and you remember in this case, here I4 will be greater than I3, will be greater than I2, will be greater than I1. So, intensity will be larger for this one, and for this one your reverse current is basically coming more value. Okay. So this is the idea you can understand. Then third eye point, what? Third eye point you need to write two application, third eye point, two applications of this photodiode, two applications of photodiode. What is this application of photodiode? A, right. So first thing is right here in light operated switch, light operated switch, and B, right, sometimes it is used also, okay, detection of optical signals, okay. So because photon and electric current relations you are getting, so photon is getting absorbed and it is changing to electric current, so that's why it can used for what? Detection of optical signals, okay. So this is the way you need to write your answer for this question number 3. So here we understand how to write subjective type questions. First you need to understand perfectly what is given in the question and what you need to write. You make a little rough thing, then after useful points write in one statement, that will be your answer, okay. I hope this video will help you. Keep watching the video, like and subscribe Vidhyalakshmi NEET Academy YouTube channel. All the very best for your turn to exam. Thank you.